kind of like verbal. So in a minute, 10 minutes, I'm going to look up these formulas and we're going to do a word problem. Don't check out during the word problem. Okay, that word problem is on the text. Okay. I'm also going to, yeah, so let's just get into it. So number one is to write the quadratic formula, which is what we were working on the last week. So the more you write it, the more likely you are to memorize it. So I've asked you to write it out. And keep writing it. Negative b plus or minus sign. Square root of b squared minus 4 times a times c. All over 2 times a. And on Friday, we kind of went about the crazy process of coming up with that formula. So we can trust that formula. We know where it came from. Number 2 is weird. What a weird question. It's like, are you a fortune teller? Which part of the formula shows what type of solutions the equations will have? The plus or minus is very important. And what's next to the plus or minus is very important. Yeah, that word is very important. So, which part of the formula? Okay. So there's one part of this whole formula that mathematicians decided is more important than all the rest. And they gave it its own name. And the most important part is the part that shows what type of solutions. How can an equation have types of solutions? What are the types of solutions a quadratic equation can have?
Real or complex?
Maybe they're real. Or maybe they're complex. What do you mean by complex? What type of numbers included in a complex?
1 plus I, negative I plus 2.
Imaginary numbers. So what part of this equation would tell us whether the quadratic has real or imaginary number solutions? This square root bar. Okay. This little bit under here, b squared minus 4 times a times c. The mathematicians really consider it kind of the most important part. This part, this is the answer to number 2, determines if the quadratic equation has real or imaginary solutions. Which part is it, Gerard? What part determines if it's real or imaginary? This whole big long equation. What part of this whole equation determines if it's real or imaginary? The part I underlined, the b squared minus 4ac. Now, they decided they should name it. They named just that part. The whole thing is a quadratic formula, but they gave that part the most special name because it determines if we're going to have a real or an imaginary. If this comes out negative, if b squared minus 4ac is less than 0, so if it's negative, we know we're square rooting a negative. We know it's imaginary. So if a scientist, a mathematician, whomever, wants to put equations into buckets of real or imaginary, they know they only want real equations. They won't do the whole formula. They'll look just at this part. If it comes out negative, they put it in the imaginary bucket. Okay? So the name for this is discriminant. It's written right here. Discriminant. So the answer to number 3. This is number 2. Number 3 is called the discriminant. And I always think this sounds like some kind of action movie. Like the Terminator. The discriminant. Dun, dun, dun. And I have to talk about discriminant for a while because in a couple of weeks you'll have a test question about the discriminant and you will swear up and down you've never heard that word before in your life, even though we're writing it down right now. So let's pull up a definition of ever heard the word discriminant before? Anybody besides Aiden heard the word discriminant before? Discrimination. Discriminate. Same word. Discrimination, you think about in terms of sociology, discrimination, gender, race, nationality. So the reason that's called discrimination is because people are classifying other humans based on their gender or their origin or their race. That's a classification. So discriminant mathematicians, they said that's the perfect word for this because this part determines whether it's real or imaginary. So it's a classification system. Now, unfortunately, discriminant in terms of sociological context is negative, but here's the actual definition. An agent or characteristic that enables things, people, or classes to be distinguished from one another. And I really like this biology application because it's like another way that it's not such a negative connotation. Anemia is commonly present in patients with both conditions and is therefore not a helpful discriminant. So looking at symptoms, doctors, nurses, biologists call symptoms discriminant or discriminatory features of certain diseases. Okay? So these symptoms help us discern or decide what a disease is. And so b squared minus 4ac helps us discern or decide what the quadratic is, real or imaginary. So it's called discriminant. Okay? So when you do an exam or an SAT, it's totally talking about this part. The vocabulary word associated that is discriminant. Okay, so I'm going to go ahead and head to, I think it's page 233, and look at the math definition now that we saw the dictionary definition. Here it is. Page 233. In the quadratic formula, the expression b squared minus 4ac is called the discriminant. Let's read it and write it. So they've highlighted this in red. You can analyze the discriminant of a quadratic equation to determine the type, the number and types of solutions. So this table has everything. Okay, this table, you want to fold this part of your book over. Maybe highlight this table. This is 233. So today's lesson, we're continuing with the quadratic formula, but we're specifically looking closely at this part under the square root bar. Because it really helps with the comprehension of square root. So I've already told you this one. If b squared minus 4ac is less than 0, there are two imaginary solutions. I want to remind you that this is a parabola with imaginary solutions. It never crosses the x-axis. If it perfectly equals 0, there's one real solution. Can anybody explain why, if b squared minus 4ac exactly equals 0, why there would only be one solution instead of two? Why does this situation happen? Josh. Yes. It only hits that one point. And Josh, what's the equation going to look like if I have a 0 in there? What happens if I get a 0 underneath there? Right, because when you square root 0, 0, there's no positive and negative 0. Adding 0 is nothing. Subtracting 0 is nothing. So this is just negative b over 2a. When the discriminant comes out just 0, you don't need the plus and minus anymore. You get one answer. The plus and minus is gone. So when it perfectly equals 0, one solution. And when it's more than 0, this is more like algebra 1 quadratics. It's always real. Two real answers. 2 x-intercepts. Okay, and then here's a great example for when you look at A, B, and C, there's not a whole lot of difference between the equations. In fact, every number is the same in these 3 problems besides which one? Which one's different? Here, A is 1, A is 1, A is 1. B is -6, B is -6, B is -6. What's changing? The C value. C is 10, C is 9, and C is 8. Now they did the discriminant for each of these, and the only number that's changing is this 8, 9, 10. So for the first one, b squared minus 4ac came out negative. So that first one we're going to put in the imaginary bucket. The second one, it perfectly equals 0, so that one has one solution. If I was looking for a parabola that exactly touches the x-axis once, I would pick letter B. The third one comes out positive 4, so that's the one that has 2 real solutions. So this discriminant helps us put these equations in different classification buckets. Let's do number 11 right now. So we're on that same page. This is the only one I'm going to do with you right now, and then I'm going to do a word problem, and then I'm done. Okay? So I know you guys want to jump right into big ideas, math, or whatever it is, and not listen, but I got 2 problems to do with you. You will have class time. So what page is this? 234, number 11. It says, it doesn't say solve. I'm not doing this whole thing. It says find the discriminant only, not the solution, just the discriminant. Describe the number and type of solution. So we're not solving it all together. And we're going to do 11. So right away, I realize that 11 has to be rearranged before I begin. So I'm going to minus the 8x over, I want this to equal 0. So that's 5x squared minus 8x equals -13. And then I'll add 13 over, and this is 5x squared minus 8x plus 13 equals 0. And now I can list A, B, and C. A is 5, B is -8, and C is 13. I'm not solving this. The directions aren't asking me to solve. They're just asking me to do the discriminant. So I'm just doing B squared minus 4 times A times C. So -8 squared minus 4 times 5 times 13. And you have a green light to put this whole thing in your calculator. Just hit enter once. You have a green light for that. I'm going to do it step by step, by hand. You have a green light to do it by hand too. If you know you want to go to the University of Florida, and you want to major in mathematics or engineering, do it by hand. Okay? They don't use calculators here. The University of Florida. No, lots of schools, but I know that one specifically. No calculators for their math program at all. So this is a 64. I like to take it step by step when I do it by hand. I'm going to do 4 times 5 first. Then I have to do 20. So multiplication before subtraction. So that's 2 times 13 is 26. So This is 0.64 minus 260. So that must be negative 196. So negative 196 is less than 0. So this, I have to use I'm going to use the table on page 233. And I'm going to say, well, what happens if your answer is less than 0? I go back to the table. Here it is. Oh, yeah, my answer came out less than 0. That means I have two imaginary solutions. So notice, okay, so I am going to go ahead and box negative 196. That's part of my answer, but this is where you're earning credit, is by identifying if it's real solutions or imaginary. Yeah. No, I looked at the table. Let me show you the table. You know the table? I use that. Yeah. When it's negative, it's always two imaginary solutions. Only one. Alright, boom, 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 skippity, skippity. Here to this one problem. Solving real life problems on page 236. So, this is a pretty important word problem. These are the formulas for objects that are dropped and objects that are projected. Okay, so you know when you see a baseball hit that it makes an arc shape. That is a parabola. Okay, those are parabolas. So we're doing the real life math of real launched objects. This is not fake, no reason to do it math. This is the real scientific properties of our natural world. Okay, so when an object is dropped, this formula will tell you how long it takes to hit the ground. This is it. The function height equals negative 16t squared plus s0 is used to model the height of a dropped object. I like to label this. S sub 0 is the initial height. That's where it starts when it's getting dropped. H is the height in feet. T is the time in motion. How long is it in the air? And S little 0 is initial height. This one, so this is object dropped. This one is launched or thrown. So if there's a velocity, we that actually shows up in the B portion of the formula. The negative 16.
That to account for an object's initial vertical velocity do not let the horizontal initial horizontal.
When you drop something right here, unless I move it this way, there's no horizontal velocity.
Object is launched from.
Yeah, when it's launched, we're including it here. This one's dropped. No movement this way. What are you trying to say? Sorry, I don't get it. All right, so this is just dropped. If it's been hit or thrown, like for instance this baseball. It's not just dropped. If it's been hit upward, your velocity is greater than 0. Is that golf? My bad. My bad. I was wondering about all that grass. Where are they hitting it from? If you're spiking a volleyball, if you're hitting it downward, your velocity is less than 0, going downward. But if you're going straight, your velocity sub 0 perfectly equals 0, parallel to the ground. Okay. And so you'll talk a lot more about velocity in physics. Yeah, there's a lot more that goes into this conversation. This is just an introduction. So let's take a look at this. This is about a juggler. A juggler tosses the ball in the air. The ball leaves the juggler's hand 4 feet above the ground. So here's where the 4 comes in at the S sub 0. It has an initial vertical velocity of 30 feet per second. That's it going straight up. So you put a 30 in the V sub 0 part. Does the ball ever reach 10 feet? Does it ever reach 25 feet? So we're going to plug it right into our formula. The negative 16 is actually the pressure of gravity. That's what that is. You can do the same problem on the moon, but we put a different number right here. Or on Mars, we put a different number right here. Negative 16 is the pressure of gravity in feet per second here on Earth. Okay? So to determine whether the ball reaches each height, you substitute for h. So here, they're saying, will the ball ever get to 10 feet? So we put a 10 in here. And then from this step to this step, your book doesn't show the minus 10. Maybe you want to write it down. It went from 4 to negative 6. That's because they make it equal 0. Subtract 10. Solve it. When h equals 10, the equation has two real solutions. It's at 10 feet, both at 23 seconds and at 1.65 seconds. It happens twice. The ball's at 10 feet, it goes up and over the vertex, and then it's at 10 feet again. So the ball is 10 feet up here and here. And those two answers are 0.2 seconds and 1.6 seconds. When h is 25, however, if you put a 25 in, 25 feet up, does it hit 25 feet up? You solve it out, it comes out imaginary. That means the ball never reaches 25 feet in the air. So, yes, the ball does reach 10 feet, but no, it will not reach 25 feet because the 25 results in an imaginary solution. All right, so everybody do number 20 right now. This is, what if the ball leaves the juggler's hand with initial vertical velocity of 40 feet per second? Is that how fast the juggler's ball goes, you think? 40 feet per second? I don't know. How would we know? How could we determine how fast the ball is moving? Yeah, we're talking circus jugglers, like Cirque du Soleil. Like these, they're going up there. This isn't the amateur juggler. They got the bowling pin. Oh, it's a ball. You can juggle humans that way if you're an acrobat. Anyways, how do we know how fast balls are going? What about baseball? What do? They talk about the speed a baseball pitcher pitches constantly. How are they doing that? Yeah, but who's coming up with the number? The radar gun. Who else uses radar guns? The police. Don't they do it with golf balls now?
Yeah. Oh, yes, they do.
Like on ESPN, they show it's like in green. They show the green arc and they show the speed of the golf ball. But yeah, that's a parabola. Okay, they're just doing algebra 2 math up there on ESPN.
Oh, bowling too. Yeah.
I think that's no. That's not what I was. Okay. All right. So on the test, I will give you this. H equals negative 16 t squared plus v sub 0 t plus s sub 0, and I will expect you to solve this. I know. Yeah, what is that? BOT. Volt. Volt. It's actually velocity times 0 times time. The S sub 0 is the initial height. Good. We're using the same data from the juggler in the example, so we're going to do height is negative 16t squared plus v sub 0t plus 4. It's leaving the juggler's hand 4 feet up, maybe like right here. Throwing his ball in the air. He's throwing his ball in the air 40 feet per second. So let's put the 40 in. Some of y'all are going to be like, we've never done a single word problem like that when we do it. This is it. So if you're not listening, you're not going to know this. So you guys got to visualize your juggler. Think about it. Maybe we should look at a juggler video. Somehow make this real. Think about when Mrs. Baldwin called that guy for a baseball player. And think back to this moment. All right, does the ball reach 20 feet? Now, 20 feet is a height, so I'm going to put the 20 in where the H is. Okay, now I want you guys to do the quadratic. Well, no, let's not do the quadratic formula. I'm going to shorten the problem up for you. I'm going to subtract 20 from both sides and set it up. Negative 16t squared plus 40t plus 4. And then I'm not going to make you solve it. All we have to do is the discriminant. If the discriminant comes out positive, yes, it reaches 20 feet. If it comes out negative, that's imaginary. No, it won't. So we're going to just do b squared minus 4 times a times c. I'm going to wait. Yeah, because it's talking about the juggler up here. Oh, you're saying I didn't ever subtract 20? My bad. Thank you, please. So let me label it for you. So in this case, A is negative 16, B is 40, and C is also negative 16. I wish I knew how fast the ball's going. Someone's drawing. I go to the circus right now. I saw people at the circus at Hunter Farms. Anybody? Was there circus people at Hunter Farms? Go ahead. What do you got? I mean, some people juggle so fast you can't even really see the ball moving. Yeah. That's what I want to know. Are we looking at a fast juggle right now or a slow juggle? No. Well, we're about to find out if it's going 20 feet in the air. And this is maybe 10 feet in here. 10 feet in here. So 20 feet is like double this, 2 stories. So I would think it's going pretty fast to go 2 stories up. That's what Aiden said. He said no one's throwing a ball 2 stories in the air. I guess so, yeah. So negative 16, negative 16. This is 1600. This is the answer, like, what is it? So what's 4 times 16 times 16? 1024?
Yeah.
And then that answer is 576. 576 is greater than 0. So this has 2 real solutions. So my answer is yes. This ball does go 20 feet in the air. It reaches a height of 20 feet. Yeah, you're saying, like, what if you just threw it like really far instead of half?
Oh, yeah, but if it's Wouldn't that mean it reaches 20 slides? And if parabola reaches 20 slides, it would have to go beyond 20. Couldn't go below.
Yes, that's what we don't know. We don't know actually how high it went. Yes, yes. Get a good visual on this, you guys. We're talking about it hitting 20 twice. So it's actually going to go higher than 20 feet. So a word problem for quadratics could say, what is the maximum height of the ball? And in that case, we would want to know the vertex. And you've already been asked that on a quiz. What was the maximum height of something? And you had to find the vertex. And that's where you go negative b over 2a and plug that in to find the vertex. Now we're actually naming any old height. How high does it go here? How high does it go there? And if we solve the formula, it's going to tell us exactly at what time it reaches 20 feet. Which would be good to know. Those, yeah. For anything that's supposed to like intersect or collide in the air, two projectiles, you have to know exactly when they reach 20 feet. So. Okay, that's it, guys. So you're on Big Ideas Math.